The cube root of a number is the number you have to cube or multiply it by itself 3 times to get the original number. So the cube root of the number 8 is the number you have to cube to get 8. The notation that we use for cube roots is very similar to that for square roots. The square root of 16 is written this way. We don't write a 2 here because without an index, this number here, it's understood that we mean the square root. If I want to ask you to take the cube root of a number, the symbol is the same, but I'll put a 3 here. The index of 3 tells me that I'm looking for the number that I need to multiply by itself 3 times to get 8. The number that I must multiply by itself 3 times to get 8 is 2. I can write 8 as 2 cubed. And just like with square roots, cubing and uncubing cancel each other out, which means the answer to this problem is 2. Something that's very different about cube roots when compared to square roots is that I can take the cube root of a negative number. Remember that what I'm looking for is the number which, when I cube it or multiply it by itself 3 times, will give me negative 8. What number do I need to multiply by itself 3 times to get negative 8? The answer is negative 2, because negative 2 cubed, which is negative 2 times itself 3 times, is negative 8. I can do this with cube roots because cubing a negative number will always give me a negative times a negative, which is positive, times a negative. And a positive times a negative is a negative. Negative 2 cubed is negative 8. Another way to write this problem, an intermediate step, is in the same way as we did this one here. The cube root of, since negative 8 can be written as negative 2 cubed, let's replace negative 8 with negative 2 cubed. When we do that, cubing and uncubing cancel each other out, leaving me with the answer negative 2, the number that was cubed and uncubed. As with square roots, I can either have the cube root of a number cubed or the cube of the cube root of a number. In other words, the cubing can occur first and then the number can be uncubed, or I can take the cube root of a number, uncube it first, and then cube it. Either way, I'm doing and undoing the same thing to the number 2 in this case. So these are equivalent, and they both equal 2. Remember when we did this problem? This is the square root because there's no index here. The square root of 9 over 64 can be thought of either as the square root of the fraction 3/8 squared, because 3 squared is 9 and 8 squared is 64, and then I'm squaring and unsquaring, so my answer is 3 over 8. Or I can think of it this way. The square root of a fraction is the square root of the numerator over the square root of the denominator. The square root of 9 is 3, and the square root of 64 is 8. Either way, I get the same answer. What about the cube root of 8 over 27? I have the same options here. I can either think of this as the cube root of the fraction I have to cube to get 8 out of 27. That turns out to be 2 over 3. Cubing and uncubing cancel each other out. So my final answer is 2/3. I could also have thought of this as the cube root of 8 over the cube root of 27. The cube root of 8 is 2, and the cube root of 27 is 3. So whichever of these two ways I think of this, this is my answer. Let's take a look at one more. Because I can take the cube root of a negative number, and I know that when I do, my answer will be negative, I can think of this problem this way. Negative the cube root of 27 over the cube root of 125. That's going to be a negative fraction. The cube root of 27 is 3, and the cube root of 125 is 5. So my answer is negative 3/5. I have another option here. I could instead think of this fraction as a negative divided by a positive, or a positive divided by a negative. When I do that, I'm choosing whether to associate the negative with either the numerator or the denominator, but not both. The cube root of negative 27 is negative 3, and the cube root of 125 is 5. This can also be written as negative 3/5.